Phyloinformatics at Work Insect Newick Review of Ahrens et al. 2014. Phylogeny of scarab beetles. Data is on Dryad. I took one of the ML trees, which looks like this. Now so they've used this type of code. This is used by Alfred Vogler and colleagues often use these. So it's a code built from the lineage. So you can see it has 2, 3, or 4 letters of each rank. So perhaps this could be the first 3 letters of a family. Perhaps this is the first 3 letters of a tribe. Then first 3 letters of a genus and part of the species. So the reason for doing this is you can cram quite a lot of taxonomic information into a short string. So when you view this in a tree viewer, you can it can be quite useful for viewing. But the issue is that these codes are, well, first they're not really a standard fixed system that you can refer to. They can change each time. If there's a minor change in the NCBI taxonomy, which these are built from, then that will change. The codes will no longer match. So you need to have a key. So if you use this type of code, you must produce a key and make this available. And they have done. Here's one of his table, supplementary table, and they've got the codes and they've got the species which these belong to. There's several issues with this. Firstly, so this reproduces as a PDF. This would be better as this data is better as a table, like an Excel table. This would make so you tend to, if you copy this into a text file, you lose the column assignments. That's a minor issue. But it means it's a bit more complex to pull out the columns, but that's not too bad. But there's some other issues with this. Here, notice they have the code and they have a superscript number which refers to like a footer, and superscripts they're not recognized by more basic text processing as used in computations. So this will be reproduced. I'll show you. So to copy this, and now it's a different number. So now this is not going to match the code. So here's a code in the tree, and when it's copied to a text to use the data, then it becomes a different number and it no longer matches. So first awkward thing was I need to manually go through and correct these numbers. If you're going to attach extra information, I would, instead of using these superscripts, I think this should be a separate column. But other issues, all number have the name, some Victorian taxonomist who presumably described this surname and date. It's either needed or it's not needed, and most of them don't, so this is not needed. I put that in a separate column if you must have it, but even that is inconsistent. Some of them are just put after the species name, and some of them are in parentheses. Other issues we have, some of them have subspecies. Now this would make sense if you have this species you had if you sequenced multiple subspecies. So for this species, then you may want to put both of these, but just to have one representative of the species and have the subspecies doesn't really make much sense. And this is from minority. There's a few of these, but these are minorities, so I need to. And another issue is we have some. So here's the code on the tree, and the key gives this melanonthine. This is not the correct way. This is kind of correct English, but it's not the correct way to. It's not the formal way. It's not a formal taxonomic name. This should be. This is a subfamily, so this should end in INAE. So it's not really correctly written, and there's a couple of cases of these. So subspecies. We have multiple species ambiguous representatives of one genus. I would put these as. I would differentiate these. These have been given identical labels. These need to be SP1, SP2, SP3, and so on. We have a genus, species, and CF after. It would be more common to see if the CF before the species name. Oh, okay. One other important thing I just remembered. So I mentioned these codes don't exactly match because of these superscript numbers, but there's another issue. There's another case in which they didn't match. Now, so sequence name, this corresponds to the sequence or the terminal of the tree. This should exactly match how it's written in a tree. If it doesn't, then you can't match them and it makes life difficult. And you can see these are slightly different. And if it's slightly different, then it's different. We've got the code, genus name, and underscore species name, and in the table, the underscore has been removed. So there's a lot of these. I started going through and adjusting these, but I had to figured out if I remove all the underscores from the Newick file and removed all the underscores from the code from the table or the mapping file, then these will match. So it's necessary, but generally you don't want to make any even a subtle change will result in you cannot match these. So that's the other main thing which needed dealing with. But after those several complexities, it worked quite nice and was able to transfer the names, check terminals, and we have 55 species ambiguous terminals, and most of them are unique to the genus, so there wasn't many I pruned. So here's some of the ones I pruned these from the genus Trox, all species ambiguous, not really informative. Here's a couple labeled to tribe, rank, and a couple to subfamily level, which are pruned. So this is the version with all the terminals processed, and we have one other issue is this tree is unrooted. It's quite common in the provision of a machine readable tree supplementary to to publication, often it's not a rooted version because this is not necessary for analysis, but we do need to do this for synthesis. So to root, but luckily they have defined the outgroups, rather large outgroup, but if we search for a couple of these, then we can see where it needs rooting, and then save tree as. So I added this to the database. Notably for Coleoptera, in the first iteration I didn't use very many source trees. The reason for this is particularly there's a couple of very large and very informative trees available, which you don't really get for elsewhere. You can see just how many huge number of terminals on these two, but still need more source trees. So I've added the one we processed today, multi-gene tree from Dryad. Give the original name of the file, 3 scripts needed to process, one of them custom written, and a few notes on the required processing. But job done, source tree processed and ready to include in syntheses.